In 7 days, it's over. On March 16th, 2026, 3I/Atlas will pass 53 million kilometers from Jupiter. After that, it continues towards Saturn, Uranus, Neptune, and then it disappears into interstellar space forever. No human telescope will ever see it again. We had 8 months. 8 months during which the best scientific arsenal humanity has ever built. Hubble, Webb, ALMA, Swift, SphereX, JUICE, Meerkat, the VLT, Gemini, Rubin, was pointed at a 2.6-kilometer object that came from somewhere else. And today, 7 days from the end, here is the list of questions we still cannot answer definitively. Where exactly did it come from? We don't know. Why are its jets separated by exactly 120 degrees? We don't know. In which direction is it actually being pushed? NASA and an independent team of researchers have been in open disagreement for 6 days. Is Jupiter going to trigger something in it? We don't know yet. And the biggest question of all, the question that nobody in the mainstream scientific community dares to ask officially, but that a Harvard astrophysicist has been asking publicly since July. That question remains, technically, unanswered. Today we do the full accounting. Everything we know, everything we don't know, and what the March 16th flyby can still teach us, or fail to teach us, before the window closes permanently. 7 days. Let's start. What we know, the definitive portrait. Let's begin with what is established. What 8 months of convergent observations have produced as a portrait of 3I/Atlas. Discovered July 1st, 2025, by the Atlas telescope in Chile. Third known interstellar object. Eccentricity 6.15. The most hyperbolic ever measured for an object passing through our solar system. Velocity at infinity, 58 kilometers per second. For comparison, Oumuamua entered at 26 kilometers per second, Borisov at 32 kilometers per second. 3I/Atlas is nearly twice as fast as its predecessors. Estimated age, 7 billion years. Our Sun is 4.6 billion years old. This object traveled through interstellar space for longer than the entire existence of our solar system. Nucleus, 2.6 kilometers in diameter, refined by Hubble post-perihelion in January 2026. Rotation period, 7.1 to 7.2 hours. Orbital inclination, 5 degrees retrograde. Almost exactly in the plane of the ecliptic, but moving backwards relative to the planets. Chemical composition, extraordinary. Webb and IR spec in August 2025, CO2 to water ratio of 7.6 plus or minus 0.3, which is 4.5 sigma above the solar system trend. A 1 in 300,000 probability of being consistent with normal cometary chemistry. ALMA in September through October 2025, methanol at 8% of total vapor, 4 times the solar average. Methanol to HCN ratio among the highest ever measured on any comet. Swift in July through August 2025, water at 40 kilograms per second at a distance from the Sun, where that rate is anomalously high. Webb MIRI in December 2025, methane detected in the deep interior, nickel vapor, nickel to iron ratio above solar norms. Morphology, 3 mini-jets at exactly 120 degrees of separation, revealed by Hubble in January 2026 via the Larsen-Sekanina technique. A 4th prominent jet pointing toward the Sun, the anti-tail. Periodic wobble of plus or minus 20 degrees over 7.1 hours. Spin axis oriented approximately 20 degrees from the sunward direction. Activity, post-perihelion acceleration. Eruption documented by SphereX in December 2025, 2 months after perihelion. Post-perihelion, outgassing shifted from CO2-dominated to CO-dominated. The surface CO2 was depleted by the perihelion passage, exposing deeper layers. Technosignatures, none. SETI's Green Bank telescope pointed at 3I/Atlas on December 18, 2025. No radio emissions detected above the detection threshold. No signals and frequency ranges associated with technological transmitters. That is the portrait. It is the portrait of an object formed in a protoplanetary disk that was colder, more carbon-rich, and older than our cosmic neighborhood. An object that behaves like a comet, but not exactly like a comet from our solar system. the question dividing the scientific community right now. I want to talk about something happening in real time, not ancient history. This week, on February 28th, 2026, Federico Spada, Małgorzata Królikowska, and Luke Dones publish on AR-14 the most comprehensive analysis ever conducted of 3I/Atlas's non-gravitational acceleration. 7,788 astrometric epochs. May 2025 through February 2026. 10 times more observations than NASA/JPL's official solution. Their conclusion: the transverse component A2 of the acceleration, the push in the direction of orbital motion sideways, is comparable in magnitude to the radial component A1, not 5 times smaller as NASA says. Comparable. On March 5th, 4 days ago, Avi Loeb publishes his response on Medium. He summarizes the finding in one sentence. The paper suggests that 3I/Atlas is pushed sideways and not simply away from the Sun. And he adds, official statements from NASA can be wrong. Science is a learning experience. Why does this difference between NASA and the Spada paper exist? Both teams use rigorous methods. NASA uses 782 carefully selected observations with their standard quality filters. Spada uses 7,788 epochs with a different error model, including more post-perihelion data. The A2 component is the most sensitive to methodological choices. It depends on how you model the object's behavior during its passage behind the Sun in October 2025, a blind window for ground-based telescopes. The difference is not physically trivial. A primarily radial push, what NASA says, is the standard signature of cometary outgassing driven by solar heating. The sunward face heats up, ice sublimates, gas escapes. The reaction pushes the nucleus away from the Sun normal. Expected. A transverse push comparable to the radial push, what Spada says, requires a different explanation. It requires gas escaping in a direction that is not primarily sunward facing. This can happen naturally if the jet geometry is specific. And the jet geometry of 3I/Atlas is precisely very specific. 3 jets at 120 degrees, spin axis 20 degrees from the sunward direction. Loeb says it explicitly. This configuration naturally favors strongly directional gas and dust emission capable of generating a transverse acceleration component comparable in magnitude to the radial one. The two observations are therefore coherent. The jets in Hubble images are physically compatible with the transverse acceleration found by Spada. 2 independent measurements converging on the same physical picture. Is that picture sufficient to explain the sideways push? Probably. But the jets themselves, their perfect 120-degree symmetry, remain without a satisfying explanation within the standard framework. The 120 degrees. Why this number won't go away? I want to spend time on the 120 degrees because it is the puzzle piece that resists every attempt at conventional explanation most stubbornly. On a natural comet, active jets form where ice is exposed, at fractures, at craters, at zones where erosion has removed the protective dust layer. These exposure zones do not distribute themselves uniformly. They do not organize themselves geometrically. They are the result of an impact history, thermal stresses, and accumulated erosion gradients over billions of years. They are, by nature, irregular. 3 jets separated by exactly 120 degrees, maintained over several months of observation, is a geometric regularity that standard cometary physics does not spontaneously produce. Loeb says it directly in his March 5th post. The symmetric system of 3 mini-jets separated equally by 120 degrees remains enigmatic. That word, enigmatic, is a scientist's word. It means, we observe this, we cannot easily explain it with standard physics, and we do not know what it means. He poses the question openly. Does it constitute a technological signature of thrusters? We do not know. He is not claiming it is technology. He is observing that the question cannot be closed by the available data. To put this in context, if you wanted to stabilize and reorient an object in 3-dimensional space with the minimum number of thrusters, how many would you need? 3. Spaced so as to cover independent axes. Satellites stabilized on 3 axes typically use thruster pairs on 3 orthogonal axes. 3 jets at 120 degrees in a plane is a different but functionally viable arrangement for attitude control. This is not proof. It is an observation of geometric coherence between what we see and what a minimal propulsion system would produce. Natural cometary physics can, under specific conditions, produce something that looks like this, but it does not predict it. It does not explain it. It tolerates it, nothing more. In 7 days, Jupiter will exert tidal forces on 3I/Atlas. If those forces trigger new jets or outbursts, new images could refine the geometry of the jet system. If the three 120-degree sources are maintained under an external gravitational perturbation, that will be additional information. If they change, that will also be information. The March 16th flyby, what it can still reveal. Let's talk about March 16th precisely, because this is not just a spectacular event to put in a YouTube title. It is a real physical test of the models that disagree with each other. 3I/Atlas will pass 0.358 Australian dollars from Jupiter, 53.6 million kilometers. Jupiter's Hill sphere, the zone where Jovian gravity dominates over solar gravity, has a radius of 0.355 Australian dollars, 53.5 million kilometers. 3I/Atlas passes at the exact boundary of this sphere within measurement uncertainty. During this passage, Jupiter will exert a gravitational deflection on 3I/Atlas. The magnitude and direction of this deflection are calculable with precision from Jupiter's mass, known with extraordinary accuracy, and the encounter geometry. Here is the test. The two disagreeing models, NASA and Spada, predict slightly different positions for 3I/Atlas at the flyby entry. Different positions mean slightly different encounter geometries. Different geometries mean slightly different deflections. And different deflections mean slightly different post-flyby trajectories. By precisely measuring where 3I/Atlas is after March 16th, in the days and weeks that follow, and comparing that position with what each model predicts, astronomers will be able to determine which of the two was more accurate. This is not a definitive resolution of the problem, but it is a new constraint in an orbital regime that neither model has yet covered. There is also the question of tidal forces. At 53 million kilometers, the gravitational gradient of Jupiter across 3I/Atlas's 2.6 kilometer diameter is tiny. It will not shatter the object, but it may induce stresses sufficient to trigger an outburst, a sudden ejection of material from a zone where ice is under tension. If this happens, we will see it in the comet's brightness in the days following March 16th. And if an outburst occurs, it exposes interior chemistry. The same interior chemistry that the December 2025 eruption began to reveal via Sphere X: methanol, methane, deep organic compounds. A new Jovian outburst would give a second window into that interior, in a different outgassing regime, dominated by CO at this distance from the Sun. JUICE, at its current position en route to Jupiter, can observe. Juno, probably still on its nominal orbit around Jupiter, can potentially point its instruments in the right direction. Ground-based telescopes equipped with CCDs will track the brightness and trajectory. Every measurement counts. The JUICE team is meeting in late March to discuss their November 2025 results. The March 16th flyby falls exactly within that window. New post-flyby astrometric data will arrive while the teams are still assembled to analyze the existing data. Juno, the decision we didn't make. I have to talk about Juno, because Juno represents the most scientifically significant missed opportunity of this entire encounter. In July 2025, Loeb, Hibbard, and Crowell publish a paper calculating that a maneuver of 2.675 kilometers per second applied to the Juno spacecraft in September 2025 could have brought Juno to intercept the trajectory of 3I/Atlas on March 14, 2026, 2 days before the Jovian flyby. Not a rendezvous, an intercept, a flyby at a distance that could have been as close as 27 million kilometers with Juno's remaining fuel reserves. Juno's instruments: infrared spectrometer, magnetometer, UV spectrograph, visible camera, particle detector, would have produced the most detailed portrait ever made of an interstellar object. Images of the nucleus, close-range coma spectra, measurements of the magnetic field or its absence. The maneuver was technically feasible. The window was September 2025. NASA never publicly confirmed executing it. budget cuts under the Trump administration, Juno's scheduled end of mission, uncertainty about remaining fuel reserves. All of this probably weighed in the decision. The result: Juno almost certainly remains on its nominal Jovian orbit. It can observe passively. JunoCam can point toward 3I/Atlas during the flyby, but not from 27 million kilometers away, from its standard orbital position around Jupiter, much farther, without the dedicated trajectory corrections. This is the most scientifically costly decision of this entire period. We had a spacecraft in orbit around Jupiter. We had an interstellar object passing within range. We had the calculations. We did not act. Why? Probably a combination of bureaucracy, budget constraints, institutional caution, and uncertainty about Juno's actual state. None of these reasons is unreasonable, but the cost is real. The opportunity to see an interstellar object up close, not from Earth hundreds of millions of kilometers away, but from tens of millions of kilometers, will not come again until the next interstellar visit, whose timing we cannot predict. Comet Interceptor, the ESA mission designed exactly for this scenario, has been waiting at L2 since 2024. It is ready. It is waiting for a target. For 3I/Atlas, it arrived too late or too slowly. Next time, perhaps. The JUICE data, what we're waiting for in late March. JUICE observed 3I/Atlas throughout November 2025 with 5 instruments. The data was received only last week, because JUICE was on the other side of the Sun during its observations, and low-rate transmission from that position takes time. The teams are analyzing right now. The meeting is scheduled for late March. What are we expecting from JUICE? Several specific things. Janus, the navigation and science camera, took more than 120 images. Processing is underway. The composite image already published on March 2nd shows a bright egg-shaped coma, a halo of gas, a long tail, and hints of jets and filaments in the processed data. The full analysis will refine the morphology, the size, the orientation of the jets in their November 2025 state before the December outbursts. MAGIS, the imaging spectrometer, collected compositional data from 66 million kilometers away. The resolution is not Webb or ALMA level, but the observing geometry is different from the other side of the Sun, at a phase angle that Earth-based telescopes could not have. Molecules detected from that angle, compared with Earth-based detections, refine the spatial distribution of chemistry in the coma. PEP, the particle detector, can characterize the interaction between the solar wind and 3I/Atlas's coma. This interaction is different for an interstellar object with unusual composition. The elevated CO2 to water ratio changes the ionospheric chemistry of the coma in ways that models predict but have not yet been tested. The JUICE November data is therefore complementary to the Webb, ALMA, SWIFT, and SphereX data. Not redundant. Complementary. Different angle, different instruments, slightly different moment, 7 days after perihelion, before the December eruption. When the teams meet in late March with both the JUICE analysis results and the first post-Jupiter flyby astrometric data, it will be the first truly complete integrated picture of 3I/Atlas, built from 9 months of observations across dozens of different platforms. What 3I/Atlas changed? The astrobiological balance sheet. Before concluding, I want to talk about what this visit has fundamentally changed in our understanding of the universe. Not a speculation, as a factual balance sheet. 3 results have implications that extend beyond 3I/Atlas itself. First result, prebiotic chemistry travels between stars, intact, over billions of years. This is no longer a hypothesis. 3I/Atlas demonstrated it. An object formed in another planetary system 7 billion years ago arrived in our solar system carrying record concentration methanol, HCN, methane in its deep interior. These molecules, the precursors of amino acids, nucleobases, sugars, survived 7 billion years of cosmic ray bombardment, absolute cold, and interstellar void. They were releasable. They were chemically active upon contact with solar heat. Weak panspermia, not life itself, but the chemical building blocks of life, is now observationally supported. For the first time. Second result, planetary systems around other stars do different chemistry than ours. The CO2 to water ratio, the methanol, the nickel, the isotopes, All of it points to a colder, older protoplanetary disk with a distinct chemical history. The universe does not produce identical comets everywhere. There is a stellar chemical diversity that translates into cometary diversity, and that diversity is now measured, not inferred. Third result, interstellar objects are common. At least one object the size of 3I/Atlas is in the inner solar system at any given moment. Population estimates based on this detection imply that Earth was bombarded by interstellar objects carrying extra-system chemistry throughout its formation. The chemistry that we are may have come, in part, from elsewhere, not as a metaphor, as a quantified physical inference. These are three results that would have been considered speculation 10 years ago. Today they are grounded in measurements, made by real instruments, on a real object, that passes 53 million kilometers from Jupiter in 7 days. He questioned that stays open. I want to close with the question I cannot close, and I want to be precise about why I cannot close it. Is 3I/Atlas natural? The honest answer is, all observations are consistent with a natural object. No observation requires an artificial object, but several observations are at the edge of what standard cometary physics predicts. Not impossible, but improbable or unexplained, or both. Loeb's list counts 15 to 16 anomalies, depending on the paper. Each anomaly taken separately has a natural explanation. The question is statistical. Can a single object accumulate this many simultaneous anomalies by chance? The 120-degree jet symmetry has no satisfying explanation. The Hill-sphere coincidence with Jupiter has a probability of 1 in 26,000. The CO2 to water ratio is 4.5 sigma out. The methanol enrichment is 4 times the norm. The non-gravitational acceleration is an open disagreement between NASA and an independent paper. SETI detected no technosignatures, which rules out an object actively emitting in radio bands. It does not rule out a passive object. Loeb gives 3I/Atlas a score of 6 on his own scale, where 0 is definitely natural and 10 is definitely technological. 6, not an assertion, a quantification of uncertainty. In 7 days, the Jupiter flyby will produce new data. In a few weeks, the JUICE teams will publish their results. Some questions will close, others will open, and then 3I/Atlas will continue. Saturn in July 2026, Uranus in April 2027, Neptune in 2028, and after that, interstellar space. Forever. Without ever transmitting a signal, without ever slowing down, without ever answering. We will have the data. We will not have the object. 7 days, 8 months of observations, dozens of instruments, hundreds of researchers, thousands of papers read, submitted, revised, contested. And in 7 days, the window closes. What we know, a 7-billion-year-old object, formed in a protoplanetary disk colder than ours, carrying prebiotic chemistry in record concentrations, with 3 jets at exactly 120 degrees and a lateral acceleration that 2 Sirius teams measure differently, is going to pass at the exact boundary of Jupiter's Hill sphere on March 16, 2026. What we don't know, where precisely it came from, what causes the perfect symmetry of its jets, which orbital model is correct, what Jupiter is going to do to it, what the JUICE data will reveal, and the question that remains technically open, that no one can close with the available data, what this object actually is. Subscribe to follow the flyby results in real time. Share this with someone who has been following 3I/Atlas since the beginning. And tell me in the comments, what do you hope Jupiter reveals? In 7 days, we'll know what we can still learn. After that, there is nothing left to learn. It will be gone.